Alright, let's look at dividing binomials, or exponents. Alright, so if I have 3 to the 7th divided by 3 to the 3rd, basically first let's write it out and see how we're getting our rules. So 3 to the 7th means I have 3 times 3 times 3 times 3 times 3. That's 1, 2, 3, 4, 5, 6, 7. Okay, that means 7 threes multiplied together. 3 to the 3rd means I have 3 threes multiplied together. So 3 times 3 times 3. Now, remember, 3 divided by 3 is 1. So let's simplify this out. There's 1, there's 1, and there's 1. Well, I'm left with 4 threes. So to write it with an exponent, my simplified version would be 3 to the 4th. Okay? Notice 7 minus 3 is also 4. So let's look at with variables. So a to the 5th. That means I have 5 a's multiplied together. 1, 2, 3, 4, 5. Okay? A to the 2nd, or a squared, means I have 2 a's multiplied together. A times a. Okay, again, simplify it out. A divided by a, just like 3 divided by 3, is 1. So that reduces to 1. That simplifies to 1. I'm left with 3a times a times a. Okay, that means in an exponent, I write it a to the 3rd power. Well, if you notice, 7 minus 3 is 4. And 5 minus 2 is 3. So we have just shown you that what our rule is for dividing exponents with the same base. Basically, for all integers m and n, and any non-zero number, a. Remember, a non-zero number is any number except 0. So if I have a to the m divided by a to the n, I'm going to do m minus n. Subtract these two exponents. Notice I do the first exponent first, then the second, no matter what number they are. So here, I'm going to subtract exponents. So let's look at this first one. M to the 9th divided by m to the 9th. Same basis, okay? You can do 9 minus 9, those are my exponents, which is m to the 0 power. Well, we know 0, anything to the 0 power is 1, so you can automatically put 1 as your simplified answer. So the second one, 8 to the 4th divided by 8 to the 6th. Do 4 minus 6, right here, and you're going to get -2. Now, we write it always with positive exponents. You notice before in a video we did 0 and negative exponents. To make this -2 a positive exponent, put it under 1. So I have 1 divided by a squared. Okay? Alright, now let's, if I can get this, let's look at a few examples. Okay? Alright, I have 10h divided by 5h to the 5th power. Now, the first thing I need to do with my constants, like 10 divided by 5, I need to actually perform that. So I'm basically simplifying this all out. So what I'm doing is 10, and then I have 3 h's times h times h times h over 5, and I have 7 h's. So 1, 2, 3, 4, 5, 6, 7. Okay? So it's like a fraction. 10 and 5, common factor, which is 5. So 5 goes into 5 one time, goes into 10 twice. Okay? That h simplifies out, that one, that one. I'm left with 4 on the bottom and a 2 on top. So if you simplify it, you're going to get 2 over h to the 4th power. Now, if I would have done that without doing all that, I did 10 divided by 5, okay, which is 2. Then you're going to do, so 10 divided by 5 is 2. Then you're going to do h to the 3rd minus 7, And that's going to give you 2 to the h minus to the negative fourth. So 2 times h to the negative fourth. Basically, I took this and wrote it with positive exponents, just like that. Okay, so let's try that with this one. Alright, so I've got 4 over 12. So first simplify that. It's just like a fraction. 4 goes into 4 one time. 4 goes into 12 3 times. Alright, 2 minus 1. So basically I have 1/3. A squared minus a to the first, remember if it's just a, it's just a positive a. B to the first minus 3, 1 minus 3 is actually going to be to the negative second. And negative 5 minus 2 is going to give me c to the negative 7. Now, I need to write it with positive exponents. Okay? 1 over, your a is positive, so you leave it on top. Your b is to the negative second power, so you bring it below with your 3 and make it positive. C to the negative 7th power, so you bring it below and make it a positive 7. Now, you don't have to write it 1 times a. You can leave it just as a, and it works because it means the same thing. All right, let's try this one. Now, notice right here, I have a power of a polynomial that we learned in multiplying binomials or exponents. So let's fix that first, okay? So I'm going to do 2 times 2, which is r to the 4th. Then I'm going to do 2 times negative 3, which is t to the negative 6. So now I have that divided by r to the 3rd, t to the 3rd. Okay, so basically what I'm going to do is with my r's, I got 4 minus 3. So r to the 4th minus 3. T is negative 6 minus 3. So t negative 6 minus 3. That's going to give me 4 minus 3 is 1. So I have r. Then negative 6 minus 3 is actually going to give me negative 9. So I have t to the negative 9th power. Okay, to write it with positive exponents, the t to the 9th goes underneath the r and becomes positive. So instead of t to the negative 9th, I have t to the positive 9th, as long as it's under r. And there is my simplified answer.